Hey, it's me again. So, I want to look over just two questions, just something I did, and I want to go over it because I did something and I did it wrong. So I feel like I just want to go over it here, and I feel like I just want to do it in front of a camera because, I love math. Math is something I like a lot, and how people like reading and how people like, drawing. But for me, it's doing math. I know it sounds weird, I know it sounds made up, but, for me, math is just fun for me. And, math is all about, correcting and, it's just fun for me and me as a person. So I'm gonna do something and hopefully I can correct myself um, doing it. So it's calculus, of course, just simple derivatives because the only higher education I do have is just calculus, specifically calculus 1. So I feel like I just want to go over a test I did, the ones I did wrong, and hopefully I can try and fix them. So the first one is saying that, let me get my markers real quick. Alright, so the first one is saying we we are given to find the tangent line to the graph of x squared plus 4y squared equals 4 at point square root of 2 negative 1 over square root of 2. Okay, let's try and break this down. So what we can do first is obviously we can just differentiate using implicit differentiation to obviously find the derivative of that. So that would be 2x plus that would be what, 8y dy dx because we're derivating y, and a constant would just be 0. So now we have to get dy dx by itself. So now what we can do is that we can subtract 2x, put it on this side, so we are left with 8y dy dx equals negative 2x, and then we can obviously just do that, and then so now we have a slope which is just dy dx equals, so negative 2, that would just be simplified into, that would just be negative 1, or not 1, that would just be over x over, so that would just be 4y. So that there is our derivative, but we want to find the tangent line of that at point, at point square root of 2 to negative 1 over square root of 2. So that is what I got. Now what we can do, we just have to plug in x and y, I believe. I think that's what I did. I'm trying to look over my paper, see what I did wrong. So apparently what I did is that, yeah, I plugged in x and y, so we don't have to do tangent line. So what I did, you just take it and you just plug in x and y into this equation. So x would be square root of 2, and then that would just be over 4, and then negative 1 over square root of 2. And then you can simplify that. So that's the answer right there. But you can actually simplify that. See what I did. So you can factor, you can bring this up here, so you'll just be left with square root of 2 over negative 4 over square root of 2, right? Look at my people right here. Then we can, actually this was a negative. So you can actually cancel the negatives. which would just be like this. So yeah, actually the negatives. Now you have this. Now what you do is that this is just key change flip. So what you can do, you can actually bring this down. You can bring this down, multiplied by the reverse of it because key change flip. And then square root of 2 to square root of 2. Well, obviously square root of that, then it'll just be 2 because the square roots cancel out. So that'll just be 2 over 4, and obviously 2 over 4 equals 1/2. So that's the answer to that question right there. And I got that wrong because I simplified it wrong, which is kind of crazy. Alright, let me get the next question up there. So that's the answer, 1/2. So the next one that we have is basically just implicit differentiation problem. So the reason why I got this wrong is because I read 3 as like let me bring this a little bit closer. I read 3 as like 2 because I did it too fast, so I combined it and I got it wrong. That's not what you're supposed to do. So let's just quickly differentiate this. So 3, you can just do it easily. So 3y squared dy dx because you're differentiating it, and then that'll just be 2y dy dx minus 5 dy dx, and then that'll just be 2, and then equals 0 because our constant is 0. So now you want to basically get dy dx by itself, and then that'll just be the differentiation problem. So what you can do first is that you can actually you can add it over here. So let me rewrite that. Now you have 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. My bad. I'll make that right just in case. 2x. Cool. Now what we can do, we can actually factor out dy dx because it's a common term for all of it. So what we can do, we can just factor out dy dx, and then we can just keep everything the same. Oops, my bad. Okay, nice. Cool. So that's what we got. Now what you can do is that you see what I did here. You can now divide. No, that's not right. No, that's right. Y squared. Oh yeah, now you just divide it by here. Okay, yeah. I don't know. I think what you do is that you just take it and then you just divide it over 2x. So actually no, let me just put that in. So it should be the answer. And then that's the differentiation of that problem. That should be right. I mean, I don't know if you can simplify that, but that should be the answer to it. 2x. I know it looks kind of bad. 2x over 3y squared plus 2y minus 5. That was like a bad minus symbol, but that should be the answer. Because you can't combine these because obviously this is squared, this is just 2y. So that's just the answer right there. So after that, other than that, that's like, I got most of the tests right. But those were my biggest problems, I guess, because 1, I don't know how to simplify crap, and 2, I guess I don't read it too fast, because that's what you get for being cocky. Don't be cocky in math, because it will backfire on you. Don't ever be cocky in math, alright? Alright, catch you guys later. I never said that in my entire life. Thanks for watching.